Alrighty, kiddos. For today, for this video, we're going to go over the Unit 6 exam study guide. I would highly recommend please have your composition notebook with you so that as we are going through this, anything that you don't understand, jot it down as a question in your composition notebook and then check in with me. All right, let's take a look at question number 1. We need to write a ratio describing Khalil, who made 3 times as many baskets as John during basketball practice. So, first off, annotate, and then we can write this a couple different ways. If we're going to represent Khalil and then we're going to represent John, whatever Khalil is, whatever John is, Khalil is going to be 3 times that. We can say 3 to 1, so that whatever John makes, Khalil is going to make 3 times that. Number 2, select all the ratios that describe the true relationship between the male teachers in a school, and there being 15 male teachers and 35 female teachers in the school. So if we have male to female, 15 to 35, we are looking for all of the ratios that are equivalent to 15 over 35. And so if we simplify 15 over 35, if we divide this by 5, we'll get 3. Divide this by 5, we get 7. All right, so we're looking to find all of the ratios that are equivalent to 3 over 7. First thing we see, 307. Hey, 35 over 15 would be incorrect because the order is incorrect. We always want to make sure we're paying attention to the order. 3 over 7, well, if we multiply that times 10, we get 30 over 7, so that's equivalent. 7 over 5 is not equivalent. 7 over 10 is not equivalent. 10 over 3 is not equivalent. And 1 over 2 is not equivalent. So the only two that are equivalent to what we saw in the question would be A and C. Let's move on. Following question says, Pam and her brother both open up a savings account and each begin with a balance of $0. For every $2 that Pam saves in her account, her brother saves 5. So describe the ratio of Pam's account. So we have Pam, and then we have Pam's brother. We saw that for every $2 that Pam saved, the brother was able to save 5. So we want to see what are the equivalent ratios for part 2, or the next part, that says if Pam has $40, well, we know the original ratio is 2 to 5 for Pam and then her brother. So if Pam has $40 in her account, how much money does her brother have? Well, to go from 2 to 40, we're multiplying by 20. So to figure out how much the brother has, we multiply by 20, which would be 100. Now, you can use this model of where it looks like a fraction. You can use the model of where it looks like with the colon. You can use a tape diagram, a double number line. Any of those models would be fine in demonstrating or modeling, depicting the relationship between Pam's account and her brother's account. Now, create another possible ratio. As long as this ratio is equivalent, it is all right. So our original ratio is 2 to 5. We could go 4 to 10. We could go, as we saw here, 40 to 100. We could go 20 to 50. As long as the ratio is equivalent, that's going to be fine. Now, as we can see here, we're using the fractions to demonstrate that or to model that. If you use the double number line between Pam and her brother, that would have been fine too, whereas originally 2 and 5. If we now said this was 6, this would be 15 because we're multiplying by 3. And if we were to say this was 30, to be able to multiply by 15, so that would be 30, and this would become 75. So any of these models are correct. Any of these models are fine. As long as they are equivalent, then you are good. All right. Next question. The ratio of Isabella's money, so Isabella's first, and Shane's money is 3 to 11. So we have Isabella, we have Shane. It's 3. Whoops. Let's erase that. Isabella, Shane, 3 to 11. If Isabella has $33, how much money does Shane have? How much money do Shane and Isabella have together? All right, so Isabella has 33. To go from 3 to 33, we're multiplying by 11. So that means we need to multiply by 11 here as well. That would give us 121. And the question we want to answer is, hey, how much do they have together? So we're adding 121 plus 33 gives us a total of 154. So the amount of money that Isabella and Shane have together would be $154. And again, your diagram is, as long as you are able to show your thinking. I know there are some kiddos, Jordan, who want to use different models. Jordan, that's okay. As long as you are showing your thinking, Jordan, then it's okay whatever model that you use. Alrighty, next question. When Carla looked out at the school parking lot, she noticed that for every 2 minivans, there were 5 other types of vehicles. All right, so we have minivans, and we're going to say other vehicles. And the ratio was 2 to 5. Carla notices that there are 161 vehicles in the parking lot. So the total is 161 vehicles. Read each statement below and decide if it is true or false based on the information given. Well, the total number of parts that we have here is 7, because 2 plus 5 is a 7. That means these 7 parts are equal to the 161 total number of vehicles in the parking lot. So what does that mean? That means to find out what one part is equal to, we would divide 161 by 7, and that would give us each part that we're looking at is equal to 23 vehicles. So that would mean 2 times 23 is 46. And then 5 times 23 would give us the total number of other vehicles. So 5 times 23 would be 115. Add those two together, we get the 161. So, true or false statements. There are more vehicles that are minivans than the other types of vehicles. Well, we know that's false because right from the jump, we were told that for every 2 minivans, there's 5. Already we can see that there's more other vehicles than minivans. Next statement. There are 23 minivans. That's incorrect. We know that each part of the ratio is equal to 23, but that doesn't mean that there are 23 total minivans. That's incorrect. There are 46 minivans. That is true because we know that each part is equal to 2. 2 times 23 gave us the 46 total number of minivans. And then 175 of the cars are other types of vehicles. We know that's incorrect because we were told, hey, the total number of vehicles was 161. Therefore, we can't have more than 161. Therefore, this is false. And we also saw that the other vehicles were equal to 115, not 175. So false, false, true, false. Next question. For every 6 hot dogs that are shipped to the store, so we have 6 hot dogs, I'm going to label this HD, 2 hamburgers are shipped. So 6, and then HB for hamburgers is going to be 2. So I'm going to use my tape diagram now. 3, 4, 5, 6, and then 1, 2. We are told that yesterday 12 hamburgers were added to making the amount of hot dogs and hamburgers shipped equal. So if we add 12, These two are now equal. How many hot dogs and hamburgers were shipped originally? Well, what do they have in common? I know this piece of tape is equal to this piece of tape, and this piece of tape is equal to this piece of tape. So these four pieces of tape that are left are equal to the 12 hamburgers, excuse me, the 12 hamburgers that were added to make these two the same. So what does that mean? If I take this 12 and divide it by 4, that means each of these pieces of tape are equal to 3. So each part in the ratio is equal to 3. Once I know that every piece of tape represents 3, how many hot dogs and hamburgers were there originally? Originally, it was the ratio was 6 to 2. 6 times 3 is equal to 18. 2 times 3 is equal to 6. So originally there were 18 hot dogs and 6 hamburgers. Next question. Josh was solving the following problem. The superintendent of highways is interested in the number of commercial vehicles that frequently use the county's highway, and he obtains information from the Department of Motor Vehicles from the month of September that finds for 14 non-commercial. So we're going to say non-commercial. There were 5 commercial. 5 commercial. So we have 14 and 5. If there were 108 more non-commercial vehicles than commercial vehicles, so that means if I have 14 pieces of tape and 5 pieces of tape, and we are told that these pieces of tape here, because that's how much more tape there is of non-commercial than commercial, is equal to 108. So if I subtract this 5 from 14, if this represents 5 pieces of tape and this represents 5 pieces of tape, that means what's left is 14 minus 5 is 9. So this 9 is equal to the 108 vehicles. Well, how would I figure out what one piece of tape is of this 9? Well, 108 divided by 9, and we get 12. Josh, though, says that he cannot solve it because 108 divided by 14 is a number with a decimal and a remainder. And because it has a remainder, that can't be true. What is the mistake that Josh is making? Find the mistake, solve it correctly. Well, the mistake we see that Josh is making is that Josh wanted to divide by the total number of non-commercial vehicles, which was 14. However, we're told that there were 108 more non-commercial vehicles than commercial vehicles. So we needed to figure out, hey, what do those more than non-commercial vehicles, what would they be equal to before we can then figure out the individual pieces of tape? And the mistake Josh was making is that he was dividing by 14, which was the total number, instead of 9, which is the more than or the additional pieces of the more than non-commercial vehicles. And when we do that, 108 divided by 108 divided by 9 is equal to 12. So each piece of tape would be equal to 12. So 14 times 12 will give us a total of 168 vehicles. And we know that non-commercial has 108 more than. Is that true? Well, 5 times 12 is equal to 60. So yes, non would have 108 more than the commercial vehicles. Let's go on to the next question. It says, after the first semester of 6th grade, the ratio of the number of math students earning an A, so we have our first semester, and kiddos who are earning an A, and kiddos who are earning a B, whoops, my mouse is acting a little funny, was 2 to 9. However, after the second semester, so now we're in the second semester, The ratio of number of students earning an A compared to the number of students earning a B, it changed from 4 to 7. Now we have these questions. The questions are, first off, how many students had a B at the end of the first semester? If there were 92 students, so first semester, 92 students who earned an A in the second semester. So second semester, 92 students earned an A. So if this ratio of 4 to 7, and this 4 represents 92, in order to figure out what one piece of tape is equal to, or one part is equal to, we go 92 divided by 4. My mouse is acting up again. Stop it, mouse. (92 divided by 4). And when we divide 92 divided by 4, we get a quotient of 23. So that means every part is equal to 23. So 2 times 23 would be 46. 9 times 23 would be 207. And 7 times 23 would be 161. All right, so in the first semester, 46 kiddos earned an A, 207 kiddos earned a B. Second semester, 92 kiddos earned an A, and 161 kiddos earned a B. With that being solved, how many students had a B at the end of the first semester? Well, as we can see here, that's 207. Question B, how many fewer students, so because it says fewer, we're going to need to subtract, how many fewer students earning an A during the first semester? First semester was 46. Then the second semester. Second semester was 92. When we subtract that, hopefully you can see that it goes from 2 to 4. It doubles it. So this is half. That would be 46 kiddos earned. 46 fewer students were earning an A the first semester compared to the second semester. Last part. If the number of students in the sixth grade changed from semester 1 to semester 2, could you figure out how many students had a B at the end of the first semester? Why or why not? Well, if the number of students changed from semester 1 to semester 2, then these total or these parts would change as well. So we would need to know what is the total number of students, and then based off of that, if the ratios were still the same, we would be able to calculate how many students earned an A versus how many students earned a B. So as long as we have those values, yes, we can figure it out. Next, a father and his young toddler are walking along the sidewalk. For every 3 steps that the father takes, the son takes 5 steps just to keep up. What is the ratio of the number of steps that the father, so father is first, 3, to the number of steps that the son takes? The son takes 5. Now remember, you could write this 3 ways. You could write it with the colon, like I did. You could write it as a fraction, 3/5. Or you can write it with the words 3, the word 2, to, and then 5. Now, create a table that shows the number of steps the son takes after the father takes 3, 6, 9, 12, 15, and 18. So we have our father, we have the son. If the father takes 3 steps, the son is 5. If the father takes 6 steps, twice as many, the son would be 10. If the father takes 9 steps, the son would be 15. If this father took 12 steps, the son would be 20. If the father took 15 steps, the son would take 25. If the father took 18 steps, the son would take 30. What can we say about the values of the ratio in the tables? Hopefully you are seeing that they are equivalent. We have equivalent ratios occurring in this table. Now for every 3 steps, the sun takes 5. We add another 3, another 5, another 3, another 5, another 3, another 5. Or if we go from 3 to 18, we multiply that by 6. 5 times 6 gives us 30. So as long as we see that it's increasing by the same amount, same value every single time, we know that one, repeating addition is the same thing. It's equivalent to multiplication. So we're multiplying or dividing by the same amount. So therefore, this ratio table is equivalent. When the father takes 24 steps, how many steps will the son will have taken? Well, we know the father starts off where the initial ratio is 3 to 5. So if we want to go from 3 to 24, we're multiplying by 8. So we'd have to do the same thing for the son. And if we multiply by 8, 5 times 8 gives us 40. The son would take 40 steps. When the son takes 75 steps, so let's go from 5 to 75. Well, that means we're multiplying by 15. So 3 times 15, what would that give us? Well, 3 times 15 is equal to 45. Therefore, the number of steps the father would take would be 45. When the father and son have taken a total of 24 steps, how many steps did the father take? Alrighty, everything seemed to disappear for a moment, so we brought it back. For this next part of the question, it says, when the father and son have taken a total of 24 steps. So we're looking to see, hey, where will, when we add the father's steps and the son's steps, be equal to 24? Well, 3 and 5, that gives us 8. 6 and 10, that gives us 16. 9 and 15 gives us 24. So there it is. When the father takes 9 steps and the son takes 15 steps, they will have a total of 24 steps. Excellent. Moving on. Alrighty, taking a look at the following. Beekeepers sometimes supplement the diet of bees with sugar water to help promote colony growth in the spring and help the bees survive through the fall and winter months. The table below shows the amount of water and the amount of sugar used in the spring and in the fall. We want to first compare the ratio of the number of cups of sugar to the number of cups of water in each table in at least 2 different ways. So let's clear everything. If we're going to look at the amount of sugar, then if we're going to compare the amounts of sugar, then we want to make sure that the water is the same. And when we look at these two, is there anywhere where the water is the same? No. However, we can use equivalent ratios by multiplying here in the fall, multiply this by 2, so that we'd have 8 cups of sugar for 4 cups of water. And now that we have 4 cups of water, now we can compare the amount of sugar because we have the same amount of water, because we multiplied this times 2, we multiplied this times 2, and we multiplied this times 2. That's how we got the 8 to 4. And we can clearly see that when the water is the same amount, when there's 4 cups of water, which one has a more sugary drink? Or which one is sugary, has more sugar? Well, the fall would have more sugar because there's only 6 cups in the spring, whereas there's 8 cups in the fall. Is there another spot where we could compare? Well, we can compare, once again, if we're going to look at the sugar and water, let's make sure that the amounts are the same again. So let's clear everything. And if we were to look, is there anywhere where, hey, is the sugar the same? Well, there isn't, but we can do the same thing of, hey, I see 30 in the amount of sugar, and I know that if I multiply 15 times 2, that'll give me 30. 15 times 2 gives me 30. 10 times 2 would give me 20. So when the sugar is the same, who has more water? The spring. That means if there's less water, it's going to be sweeter. Just like we saw already, that when there was 8 cups of sugar, there was 4 cups of water. So in both of these situations, we can clearly see that the fall has more sugar than the spring. So when we compare the ratios, and we're comparing the amount of sugar to the amount of water in each in 2 different ways, we were able to see that the fall is sweeter because there's more sugar. Fall has more sugar. All right. Now we're told create a third ratio table for the summer. And we want the mixtures for the summer, for all 4 rows, to be more sugary than both the spring and the fall. Well, we saw when there was 4 cups of water, the spring had 6 cups of sugar, the fall had 8 cups of sugar. So let's do more than both of them, and we're going to go with 10 cups of sugar. Once we know this ratio of 10 cups of sugar to 4 cups of water is more sugary than what we saw in the other 2, then all we have to do from here is just make sure that these ratios stay equivalent. So we're going to double this, make it 20 cups of sugar with 8 cups of water, and then 30 cups of sugar with 12 cups of water, and then 40 cups of sugar with 16 cups of water. And we could keep going and going and going as long as they're equivalent. But because they just told us 4 rows, that's why we're going to stop at 4. All right, Kyra is participating in a fundraiser walkathon. She walks 2 miles in 30 minutes. So we have miles, whoops, and we have minutes. You see she's walking 2 miles for 30 minutes. If she continues to walk at the same rate, determine how many minutes it will take her to walk 12 miles using the double number line. Well, because we're told to use the double number line, this is why we're going to use this particular model. To go from 2 to 12, we're multiplying by 6. So we're going to multiply this by 6, which will give us 180 minutes. We could write this as 180 minutes, and 180 minutes is equivalent to 3 hours. We're now told that Kyla, while shopping, found a dress that she would like to purchase, but it's $49.50 more than she has. Kyla charges $5.50 an hour for babysitting. She wants to figure out how many hours she must babysit to earn $49.50 to buy the dress. So we have the money that Kyla would like, and we have the number of hours that she's going to babysit. We know that she will charge $5.50 for every hour of babysitting. And we want to figure out, hey, if she's going to earn $49.50, how many hours will that be? Well, $5.50, when we multiply that times 9, that's how we get $49.50. We could figure that out by dividing $49.50 divided by 550. That's how we got the 9. And if we multiply this by 9, that's equal to 9. And this 9 in this context represents the number of hours that Kyla would have to work in order to earn $49.50. Great. Looking at the next one. At a restaurant, for every 13 people that come in, they have to push together 3 tables. So down here, we're going to have this be tables. And we're going to have this part be the number of people. And we're going to pause here for a second.